solution. As we know, buffer solution keeping the pH steady. Buffer solution are like chemical superheroes, protecting the pH of a solution from unwanted changes. Imagine you have a perfectly balanced pH, like the ideal temperature for brewing tea. Adding a little lemon juice acid or baking soda base could throw everything off running your tea, but not if you have a buffer solution on your side. What are a buffer solution? A buffer solution is a mixture of weak acid and its conjugated base, or a weak base with and its conjugate acid. This dynamic duo works together to neutralize small changes in pH, keeping it within a desired range. How do they work? Let's imagine you add some acid to a buffer solution containing acetic acid and the sodium acetate. The acid attack H ions from the added acid, bump into the acetate ion from the sodium acetate. Neutralization happens. The H and the CH3COO, these radical ions, combine to form uncharged acetic acid molecule. This the negative ion with the positive ion form the CH3COOH, effectively removing the added acid effect. The base takes over. If you add base instead, it will snatch H positive, the ions of hydrogen ion from the acetic acid molecule, converting them back into acetate ion. This also neutralizes the base pH change. Why are buffer solutions important? Buffer solutions are crucial in various fields. Biology maintain the optimal pH for enzymes, cell and other biological processes. Chemistry controlling pH in chemical reaction and calibrating instrument. Food science preserving the texture and flavor of the food. Medicine stabilizing pharmaceutical and regulating pH. By carefully choosing and using appropriate buffer solutions, researchers can optimize their ELISA assay for accurate and reproducible detection of target analytes. Example of buffer solution: citric acid, sodium citrate used in food and beverages. Phosphate buffer common in biological research. HBES buffer used in cell culture enzyme assay. Absolutely, buffer solution play a crucial role in the success of enzyme-linked immunosorbent assay, ensuring optimal pH condition for various stages of the process. There are important types of buffers used in ELISA. Coating buffer. This buffer help absorb and capture the antibody onto the ELISA plate. A common choice is phosphate buffer saline. BPS at 7.5, promoting stable binding while minimize non-specific interaction. Blocking buffer. This buffer blocks any remaining binding sites on the plate to prevent non-specific binding of other molecules like protein or detergent. Bovine serum, albumin, or milk solution are often used, although commercial blocking a buffer with defined composition are also available. Wash buffer. This buffer removes unbound component like excess antibodies, diluent, blocking agent after each incubation steps. Phosphate buffer with 20, a mild detergent, is commonly used for its efficient washing ability with minimized antibody elution. Assay buffer. This buffer dilute the sample and detection antibody, maintain a stable pH for optimal antibody antigen binding. Trace buffer saline is common choice for its compatibility with various enzyme and substrate. Substrate buffer. This buffer prepare the enzyme substrate for the final colorimetric or chemiluminescent detection step. Commonly used as substrate includes citrate phosphate buffer and diethanolamine buffer, chosen based on the specific enzyme and desired signal intensity. Why are buffer solution important in ELISA? Maintain optimal pH. Each step in ELISA has a preferred pH range for efficient binding reaction and enzyme activity. Buffer prevent drastic pH changes due to sample, component or reagent, ensuring the assay accuracy and sensitivity. Minimize non-specific binding. Unwanted interactions between molecules can lead to background noise and false positive. Buffer like BSA or tween 20 block these interactions, improving the assay specificity. Stabilize enzyme and antibodies. Proteins like enzyme and the antibodies are sensitive to pH change. Buffer maintain their optimal conformation and activity throughout the ELISA procedures. Improve reproducibility. Consistent pH condition across different experiments and laboratories ensure reliable and comparable results.